All right, in this lesson, we'll explore some of the methods and attributes that are shared between a pandas series object and a pandas data frame object. Now, a method at the end of the day is just a message to an object. It's a command, it's a direction. It says, do this thing for me. And different objects can respond to the same message. Even though they are different objects, they have a different structure, they can still respond to the same message. The series and data frame are two different objects. One is one-dimensional, one is two-dimensional, but that doesn't mean that there's things that they don't have in common. So the series and data frame objects do share many methods in common. In addition, both of them have their own exclusive methods. There are things that only a series can do or respond to. There are things that only a data frame can do or respond to based on that object's inherent structure. So as an example, let's begin by re-executing our code to load our NBA CSV. And we've become pretty familiar with the head method on a series in the last module. The head method by default returns the first 5 rows. Well, on a data frame, we can also call the head method. I'm going to use .head and just place my parentheses there. And it's going to do the exact same thing. It's going to give me a brand new data frame with just the first 5 rows of data from my original NBA data frame. Similarly, this method takes its own argument, which is going to be a custom number of rows. So if I instead want to return the first 7 rows from my NBA data frame, I can do that. If I want the top 3 rows, I can do that. If I want only the top row of my data frame, I can do NBA.head and pass 1 as the argument. So even though this is a completely different object, it's a data frame, it still has the head method. And predictably, it also has the tail method. If I want the last 5 rows of my data frame, I can follow the exact same syntax, just use my variable that's holding the data frame, a dot to call a method or ask for an attribute, and then the name of it. If it's a method like tail, I do need the parentheses. And then I'm going to get the last 5 rows of my data frame. You'll see that unfortunate row at the end that has all of those null values. So again, series and data frames have many things in common, and it's not just methods, it's also attributes. For example, in the cell below, we have a familiar index attribute that I can call on a data frame. And just like with my series, I'm going to get an object here that represents what's storing the values in my index. In this case, it's a range index object that's going to start at 0 and proceed all the way up to 458, incrementing by 1 step. I also have the familiar values attribute, also available on a data frame. And this time I'm going to get a nested array or a multidimensional array of all of the values within my data frame. You can see here that each row is basically going to be represented as its own custom list or array within my larger outer array as well. We have the shape attribute. This was kind of particularly not really helpful on a series because a series is one-dimensional, but on a two-dimensional object like a data frame, the shape attribute will return a Python tuple that will tell you how many rows there are and how many columns. So this NBA data frame has 458 rows by 9 columns. We also have the dtypes attribute, which is short for data types. Of course, when we call this on a series, we would just get one answer because that column basically had one data type. But now we're going to get a brand new series when we call the dtypes attribute on a data frame. And in this new series, you can see that the index labels represent the column names from my series, from my data frame, sorry. And the values here represent the values of the data that are being stored within that column. So in my name column, if I just preview my first 5 rows below, in my name column, I have an object, which basically means string. Same thing goes for team. And then in number, I have a floating point, and so on and so forth. It's going to basically give me the data type of every single column within my data frame. So the attribute name remains the same, but the way it operates is a little bit different. Let's take a look at some other ones. We have now some exclusive attributes as well. So these are things that are now available because our object is different. So for example, a data frame has an attribute called columns. Predictably, this attribute isn't available on a series because a series doesn't have columns. It's just one basic array, essentially. But the data frame does have a columns attribute, and that's going to give me an array that's going to represent my column names. And one of the additional things we have on a data frame is an axes attribute. And basically what this does is combine the axes that make up my data frame. So it's going to combine the index, which is our first object here, That's what we saw when we called nba.index. And right below, we're going to get the second index, so to speak, which is our vertical one, which is our columns. And this is going to represent the result of calling the columns attribute on the data frame. So this axis attribute basically bundles those two together into one single output. In addition, we have exclusive methods that are now available on a data frame that are not present on a series. One of the most popular ones is called info. And what info does is provide a summary of the data frame. You can see here that's basically giving us a lot of output, but you can see here we begin with a summary that it is a data frame. We can see that familiar range index object, which is telling us how many entries we have. We're going to see that we have a total of 9 columns. Here they are represented again. We also have the number of non-null values within each column, so we can quickly identify that, oh, in college we actually have some missing values because this number is significantly lower than numbers up here. We also have some null values in the salary column because this number, 446, is also smaller than 457. So there are some salaries that are missing. Right below, we see a count of the number of data types. So we can see here that 4 columns, that's the number in the parentheses here, 4 columns have floating point numbers, and 5 columns in this data frame have objects, which basically means strings. And finally, at the very bottom, we have the memory usage, which represents how much memory this data frame is taking up in our computer. This info method, again, is not available on a series. This is exclusive to a data frame. And finally, one more method, just to give you a general picture, is the get dtype counts method. And this is basically going to give us this piece of information from our all-inclusive info method. Get dtype counts is just going to give me a series where the index labels are going to represent the data types, and the values are going to represent how many columns within my data frame are storing that kind of data type. This, again, is an exclusive method to the data frame because a series does not have multiple columns, so it doesn't have multiple data types that you can count. A data frame does. Now, it's not important that you memorize all of these methods and attributes all at once. Really, the key takeaway of this lesson is just to understand that these are 2 separate objects. They're totally independent, but they do share things in common, and they also have unique features of them as well. So certain methods are going to be available on both a series and a data frame. Certain attributes are going to be available on both, and certain methods and attributes are only going to be available on one or the other.